Okay, right. So we are now in question 9. So they say that in the diagram below, the graphs of f of x equals to ax to the third plus bx squared plus cx plus d and g of x equals to 2 over x plus p plus q are given. E is a point of inflection, is a point of intersection of the graphs of f and g. So that's the point there. Then they say that f is the point of inflection of f, and that's the point there. Then they say that the graph of f cuts the x-axis at a half, touches it again at -3, and cuts the y-axis at at 9, which is here. Right, so in the way in that we can actually to try finding the equation of the cubic function, because this, ne, let me use a different color. So this function there, we normally refer to it as the cubic function. All right, and then the method to actually try finding the equation of the cubic function, we are given as y equals to ax minus x1 close bracket x minus x2 close bracket, and then x minus x3 and then close the bracket. Now, but what I want you to look here, can you see that the cubic function only cuts the x-axis twice? Can you see that it only cuts the x? If it cuts at the x-axis 3 times, then that will be valid. But in a way in which we can rearrange this formula so that we can make it valid for when it only cuts the x-axis twice, it's when you're gonna now say, using a different color, we can say therefore y equals to a x minus 1 squared, and then say x minus x2. That can be valid for when that cubic function cuts the x-axis 1 and 2. Now remember that x1 there and that x2 there, it stands for the x-intercept. So we call this kind of form the x-intercept form. So both the black one and this one, we call it the x-intercept form. Now remember, we are given in the equation that the x-intercepts, it's first -3, so we're going to say x plus 3 squared, and then they say that the second one is a half, so we're going to say minus a half. All right, so now basically what we need is to solve for a. So we have already found what's happening for the x1 and the x2, so we now need to solve for a. Now remember, they said that the parabol, not the parabol, the cubic function cuts the x-axis, it cuts it here and there, and it also cuts the y-axis here. So basically what's actually happening then, that we call a y-intercept. So basically the coordinate there, it's 0, 9. So we're gonna say substitute 0, 9. Then if we do, we should get 9 equals to a 0 plus 3 squared, 0 minus 1 over 2, using a calculator. So we're going to get 9 equals to, then using a calculator, 0 plus 3 squared times 0 minus 1 over 2, we get 8 times -9 over -9 over 2. Right, and then to get rid of that -9 over 2, we can actually multiply both sides of the equation by -2 over 9. So we're going to say 9 times -2 over 9 equals to a minus 9 over 2 times -2 over 9. then you should get an answer of A being -2. Right. So basically the equation now we have it as y equals to minus 2x plus 3x squared multiplied by minus 1 over 2, right? Now we need to expand it. Now to expand it, we can say using using the same color, we can say minus 2. We can first deal with the x plus 3 to the square because this part here we call it the perfect square. So we can say x squared plus 6x plus 9 times x minus 1 over 2. Then now we're going to use the distributive law. So we're going to use the distributive law starting with the x going in there and then coming with the half going in there as well, right? Then we're going to say equals to minus 2, then x times x times x squared we give is going to give us x third plus 6x times x 6x squared plus 9x. Then the next step we're going to say it's going to be minus x squared over 2 it's going to be minus x squared over 2, then it's going to be minus 3x, then it's going to be minus 9 over 2. Okay, and then we're going to say minus minus the x squared, the x to the cubed is going to remain the same. Then we're going to say, I'm sorry, they were supposed to put a square there, sorry. Then we can say 6 minus 1 over 2, we get 11 plus 11 over 2x squared. Then we can say 9 minus 3 plus 6x, because it's basically we are basically collecting the like term. That's the like term with this one, and that is also the like term with that one. Then we should also have minus 9 over 2, and then multiplying with the 2 multiplying with the 2 inside there, we should now get minus 2x third minus 11x squared minus 12x plus 9. Right, so now we can say therefore A equals to minus 2, and then B equals to minus 11, C equals to minus 12, and then D is equals to 9, as we can see from this given equation there. Alright, so that's how you could have actually solved for this question here. Hope that is clear and understandable.